All right, let's talk about the invisible manager of our online world, the session layer. It's the real reason your video calls don't just randomly drop, and why your huge downloads can actually survive a network hiccup. So, how does it all work? Let's dive in.
Oh, we've all been there, right? You're like 90% through downloading a massive file and poof, your Wi-Fi drops. You have that sinking feeling thinking you've got to start all over again, but then it just picks up right where it left off. How is that even possible? Well, the answer lies in the session layer.
So let's meet layer 5 of the OSI model, the session layer. The best way to think of it is as the ultimate conversation manager for your applications. Seriously. While other layers are just shuffling data packets around, the session layer is focused on the actual dialogue. Setting it up, keeping it going, and then ending it nicely when you're done.
So, what even is a session? Well, think of it as a dedicated ongoing chat between two different apps. It's not just one single message going back and forth. It's a whole interaction that has a clear beginning, a middle, and an end. And look, this isn't just some abstract techie thing. Sessions are literally happening all around us all the time. That video call you have with your team, that's a session. Logging into another computer from your own, that's a session. Downloading a huge game update, connecting securely to your bank, even that intense online game you're playing, yep, all of those are managed as their own distinct sessions. Every single one of these sessions follows a pretty clear life cycle, all handled by layer 5. First up, you have establishment, where it basically negotiates the rules of the conversation. Then comes the maintenance phase, where it's managing the back and forth and keeping things active. And finally, when it's all over, termination makes sure everything ends cleanly. No loose ends, no mess. Okay, but how does it actually do that? How does it keep the conversation so stable and orderly? Let's get into the mechanics because this is where the session layer gets really powerful. One of its key jobs is something called dialogue control. It's basically deciding who gets to talk and when. In half-duplex mode, it's just like a walkie-talkie. Only one person can talk at a time. You say your piece, then you say over. But in full duplex mode, it's a telephone call. Both sides can talk and listen at the same time. The session layer manages this whole process to make sure it's not just total chaos. And now we get to the absolute hero feature of the session layer, checkpointing. This right here is the magic that lets you resume a failed download. So here's how it works. Just imagine you're transferring a huge file. As that data is flowing, the session layer is sneakily inserting these things called checkpoints or synchronization points. Let's say it saves one at the 1 GB mark and another at 2 gigs. And then, bam, the network fails. Well, instead of starting all the way back at 0, the session layer knows that the last good checkpoint was at 2 GB. It just reestablishes the connection and picks things up from that exact spot. It's just brilliant. And that's the whole ball game right there. For any long or really important transfer, being able to continue from a checkpoint instead of starting over from scratch is what makes the connection truly reliable and efficient. It's a lifesaver, especially when you know networks are never perfect. Okay, so we've covered the theory, it all sounds great, but where does this stuff actually live in the technology we use every single day? Let's connect the dots. First, let's clear up something that trips a lot of people up. The difference between layer 4, the transport layer, and our friend layer 5, the session layer. Think of it like this. The transport layer is the postal service. Its only job is to get the data from point A to point B reliably. The session layer, it's the project manager. It's overseeing the entire conversation, the context, the timing, the recovery plan, the whole shebang. And you can see these session layer principles at work absolutely everywhere. When a database keeps your connection open and active, that's a session. A voice over IP phone call is a session. When one computer asks another to run a program using something called a remote procedure call, that's all managed as a session. Even that little padlock you see in your browser, the secure TLS connection for HTTPS, it uses these exact same principles. But here's a bit of a modern twist. The way we think about these layers today isn't quite as rigid as it used to be. The classic OSI model has, well, it's evolved. See, in the real world, you won't always find a separate, distinct protocol that's just for the session layer. Instead, it's critical jobs, managing the dialogue, handling the state, doing that checkpointing. They're so important that they've often just been absorbed directly into layer 7, the application layer itself. So where did those functions go? Well, you'll find them baked right into modern protocols like HTTP/2, which keeps connections persistent, or the secure shell, SSH, that you use to log into servers. They're in TLS for security and in high-performance frameworks like gRPC. The responsibilities didn't just vanish, they just moved up the ladder. So, what's the big takeaway here? It's this. Even if you can't always point to a separate layer 5 on a chart anymore, the job of managing sessions is more critical than ever. It is the fundamental logic that keeps our digital conversations stable, reliable, and sane. And that kind of leaves us with a really fascinating question to think about. As we move into this new era of more immersive, real-time apps, things like the metaverse or collaborative augmented reality, how is our definition of a session going to need to change? What will the conversation managers of the future even look like?